Hello, my name is Aryan Kumar and the topic which I am going to demonstrate is projectile motion. So basically we have to understand what is projectile motion and how it is different from linear motion. So as we know, in linear motion we deals with one dimensional or one directional motion, but in case of projectile motion we deal with the motion in a plane. It means we have to deal with both vertical and horizontal distances and velocities, acceleration as well. And the finest example of projectile motion is throwing a basketball. So if I take a graphical representation of projectile motion, then it would be something like this. And we have to remember one thing: while the body is in motion or the body is in air, the only force which is acting over it is mg, and the acceleration over it is g, that is vertically downward. So I'm considering this direction as positive and downwards as negative, which we use to symbolize our velocities and acceleration in further explanation. So I I think this equation must be clear to all of us. I'm guessing that all the symbols are understandable. So if we talk about the motion, then at the initial part it must be having some velocity. I'm considering it as velocity v with angle alpha with respect to horizontal. So the first thing which we have to do, we have to divide the given velocity into its component. And as we know, the component in x and y direction will be v cos alpha and v sin alpha. So in case of projectile motion, we are interested in four things. These four things are time of flight, maximum height, maximum range, and equation of trajectory. So the very first point is time of flight. As I had already mentioned, and let me mention it again, these are the components of velocity, that is v cos alpha and v sin alpha. The only acceleration which is acting on this body is g, and that is vertically downward direction. So by the three equation of kinematics, we will get to know that at the point of maximum height, it would cover half of the range and half of the time, and the time which it would take to reach here would be the time which acceleration will take to make this velocity as 0. And we know that, as we have already mentioned the three equation, that is alpha. This is the time it would take to reach maximum height, but it is half of the complete time. So we have to take a multiplication of 2, and time of flight would be now we have to, the second thing which in we are interested are maximum height. The maximum height it would take. Again we will use the equation of kinematics, that is v square equals to u square plus 2as. Since we are talking in vertical direction, the final velocity at the maximum height is 0, and the acceleration which we are considering is minus g. So basically maximum height which we are denoting by s would be u, initial velocity, which is v sin theta, sin alpha, sorry, v sin alpha to the whole square by 2g. This is the maximum height it would take. So let me mention it more clearly. V sin alpha whole square by 2g. Now we are interested in range, maximum range which it would cover. So as I had already mentioned that velocity in horizontal direction will be constant, and we are considering, or we are assuming that when the body will reach at this point, will reach at the ground level, the motion will be stopped. So according to our assumptions, we will get to know that if we take the component of horizontal velocity and the total time of travel, then we would get the maximum range. We have the time of flight 2v sin alpha by g into horizontal velocity, that is v cos alpha. So it is 2v square sin alpha cos alpha by g. By using identity of trigonometry, we could also write as b square sin 2 alpha by g. I hope it must be clear to you now. Now we are focusing on equation of trajectory. Equation of trajectory means we are going to establish a relation between its horizontal and vertical distances at a given particular time. So basically we have to establish a relation. So we know a few things, and let's say horizontal distance at any time t would be okay, and if we write equation for vertical distance, then it would be this is nothing but one of the equation of three equation from kinematics, and we are utilizing it. And now what we have to do, we have to substitute t from the equation number 1 to equation number 2, and we will get something like this. Now using very basic things, we will get to know that our equation is x times of sin alpha by cos alpha, I am writing it directly tan alpha, minus 1 by 2 g x square u square cos square alpha. We know very well that 1 upon cos square alpha is sec square alpha, and sec square alpha is nothing but 1 plus tan square alpha. So basically in this equation, alpha is constant, initial velocity is constant, g is constant as we know. So it is a relationship between horizontal and vertical distances. till now we have learned while our motion was on a straight line. Now we are considering that our motion is not straight, it is inclined. So first case is inclined up. This is a surface, let's say OAB. OA is a surface at which a particle is thrown with initial velocity u at an angle alpha with respect to horizontal. We have to consider one thing. We are denoting the origin and the direction of x and y coordinate in this way. And now we have to write various equations, which is velocity in x direction, velocity in y direction, acceleration in x direction, and acceleration in y direction. Because we know it very well, even no matter how the motion is or how the trajectory is, the only force which is acting on it is mg, and that is completely vertical downward direction. So here this acceleration will affect both horizontal and vertical direction. Now since we are more focusing on like our new study system, then we will get to know that velocity in x direction is u cos alpha minus beta, u sin alpha minus beta. Acceleration in x direction would be minus g sin alpha, and acceleration in y direction is minus g cos alpha. So now we have to look for what is the time of flight. We are using the same concept which we have used in previous case, that we will take we will take the velocity in vertical direction, acceleration is opposite in the vertical direction, and we will take the time which acceleration will take to make the velocity 0, and we are considering this, the time taken by acceleration to make the velocity 0 is the topmost point, and it is half of the total time which is taken for the motion. So it would be ub. So this would be the time of flight which it would take. Now we are more interested in finding range. In range we will use the same concept of which we have already used, that is total time of flight into velocity in horizontal direction. So I'm more very interested in the distance OV which it is covered instead of OC. However, both could be like calculated very easily. We could use the simple trigonometric principle and it could be done. And it would be the time of flight, that is u sin alpha minus beta by g cos alpha into u cos alpha. And this is the distance covered in horizontal direction, that is OB. And OC could also be calculated, that is OC cos beta equals to OB. So this is how this time of flight and this maximum range which it would cover could be calculated. Later on, if we want to go for the maximum height or equation of trajectory for this, could be done in a similar manner. And this is from all my side. Thank you.